You're standing in a pharmacy, fluorescent lights, rows of white boxes. A pharmacist in a lab coat hands you something that took 12 years and $2.6 billion to develop. You take it home. You follow the dosage. 2 weeks later, you're slightly better. Now imagine a different scene. A healer in the highlands of Peru 500 years ago, pressing the bark of a tree into your hands. No lab, no clinical trial, no patent, just bark. And the fever breaks. If modern drugs are so advanced, if we've had a century of pharmaceutical science, electron microscopes, and randomized controlled trials, why are the biggest drug companies on Earth spending billions of dollars trying to copy what ancient healers already had? The answer isn't one thing. It's never just one thing. There are layers here, and each layer is more disorienting than the last. We're going to talk about synergy, about evolutionary arms races, about receptor systems in your body that appear to have been waiting for plants your whole life. We're going to talk about what medicine lost when it decided that simple was better than complex. And we're going to end somewhere you didn't expect when this started. Let's go. The first thing everyone gets wrong is this. People assume that when scientists isolate the active ingredient from a plant, they've made it more powerful, purer, more targeted. What actually happens, often, is the opposite. In 2017, Thomas Efferth at the German Cancer Research Center in Heidelberg published a study in Phytomedicine showing that whole Artemisia annua plant extract outperformed isolated artemisinin against drug-resistant Plasmodium falciparum malaria strains by 3 to 4 times. The same pattern appears in St. John's wort isolated hypericin consistently underperforms the full-spectrum extract because the flavonoid hyperforin is doing a completely different neurochemical job in parallel. Saw Palmetto. Same story. Cochrane Review 1998. The isolated beta-cytosterol underperforms the whole lipid sterol extract every time. Why? Because a plant isn't a delivery vehicle for one compound. It's a buffered chemical ecosystem. Phenols regulate absorption rate. Terpenes alter how permeable your cell membranes are. Alkaloids potentiate receptor binding. Remove one, and the others misfire. This is the entourage effect studied extensively in cannabinoids, but present across nearly every medicinal plant family on Earth. The plant wasn't the delivery vehicle. The plant was the drug. Now let's talk about bacteria. People assume antibiotics are our most sophisticated weapon against bacterial infection because scientists designed them. But plants invented antibacterial chemistry 450 million years before Alexander Fleming discovered penicillin. And they invented it under sustained evolutionary pressure, which means they didn't just solve the problem once. They built solutions that are nearly impossible to circumvent. In 1999, Marissa Cowan, at the American Society for Microbiology, cataloged over 1,340 plant species with documented antimicrobial activity and found that plant-derived antimicrobials typically attack 3 to 5 simultaneous bacterial targets. Most synthetic antibiotics attack 1 or 2. Allicin from garlic attacks cell membranes, enzyme systems, and DNA repair simultaneously. MRSA has shown 0 documented allicin resistance in decades of clinical study. Berberine from barberry has been used for gastrointestinal infections in Chinese and Ayurvedic medicine for 3,000 years. Still no documented clinical resistance pattern. Oregano's carvacrol disrupts bacterial quorum, sensing the way bacteria coordinate their attacks. Single-target antibiotics cannot touch that mechanism. Plants can't run from pathogens, so they evolved multi-tools. Bacteria have been trying to outsmart plants for 500 million years. They haven't managed it yet. Here's something else that almost never comes up. Your body is not a neutral vessel that drugs act upon from the outside. Jörg Gertsch at the University of Bern published a study in the British Journal of Pharmacology in 2008 demonstrating that the human endocannabinoid system, which regulates inflammation, pain, mood, and immune response responds to beta-caryophyllene, a terpene found in black pepper, cloves, and cannabis, as a full agonist at CB2 receptors, meaning your body has a receptor that responds to a plant compound as if it were expecting it. Curcumin activates NERF, 2 pathways, master regulators of antioxidant response pathways that evolved to respond to plant polyphenols specifically. Resveratrol activates SIRT, one sirtuin's longevity proteins that appear calibrated to still being compounds present in ancestral human diets. Homo sapiens evolved eating hundreds of plant species every single day. Our metabolic, inflammatory, and neurological systems were calibrated across 300,000 years of constant plant compound exposure. Your body didn't evolve in a lab. It evolved in a forest. But here's what nobody in this conversation tells you. Plants have also killed people. And the cases where they did reveal something even more disturbing about why modern medicine stepped back from them in the first place. Belgium, 1990 to 1992. A weight loss clinic in Brussels accidentally substituted Aristolochia fangqi for Stephania tetrandra in a slimming formula. Two plants with similar sounding Chinese names, pharmacologically opposite in safety profiles. Over 100 patients developed end-stage renal failure. 18 required kidney transplants. By 2001, follow-up studies found that 46% of exposed patients had developed urothelial carcinoma. Not because plant medicine failed, because the knowledge that encoded how to use it safely was stripped away at the moment of commercial repackaging. The same thing happened with comfrey throughout the 1970s and 80s. Traditional European use restricted comfrey to topical application. Only the tradition had evolved to prevent exactly the hepatotoxicity that oral use causes. The moment comfrey was sold as an internal supplement, disconnected from that restriction, it caused veno-occlusive liver disease across documented cases in the US, UK, and Australia. The plant wasn't the problem. The broken transmission of knowledge was. And if that sounds familiar, it should. Effective pain drugs, stripped of clinical context and dose regulation, gave us the opioid crisis. Decontextualization is the danger, not the compound. There's one last thing I saved for the end. Because the question we started with, why are pharmaceutical companies spending billions to copy what ancient healers already had, has an answer that has almost nothing to do with efficacy. Plants cannot be patented. A compound any farmer can grow cannot return a $2.6 billion drug development investment. The Tufts Center for Drug Development calculated that number in 2014 as the average cost of getting a single FDA-approved drug to market. No patent means no return. No return means no investment. The 20th century pivot to single-molecule synthetic drugs was not driven purely by clinical superiority. It was driven by intellectual property law. The ancient healers weren't primitive. They were operating inside a system with zero profit motive, where knowledge accumulated freely across generations and was encoded in the plants themselves. The moment medicine became an industry, the incentive shifted from what works best to what can be owned. Plants fell out of mainstream medicine not because they stopped working. They fell out because they were never ownable. And now, with over $50 billion invested in natural compound drug discovery, as of the early 2020s, the pharmaceutical industry is paying scientists to rediscover what indigenous knowledge systems already documented across millennia. The most expensive drug discovery programs in human history are trying to find their way back to the forest. We didn't advance past plant medicine. We abandoned it, and now we're paying to find our way back. So go back to that pharmacy. Fluorescent lights, white boxes, a compound that took 12 years to reach the shelf. The healer in the Peruvian highlands had a version of this encoded not in a patent filing, not in a peer-reviewed journal, but in the chemistry of the bark itself. In the preparation method passed down across generations. In the knowledge of which plant, which part, which season, which dose, that knowledge lived inside the plants and inside the people who understood them. We called it superstition. We called it folk medicine. We built an industry to replace it, and now that industry is spending billions searching for what it threw away. The plants remembered. We're the ones who forgot.